Okay, you have the next 3 minutes to work on to do now while I finish getting this up on my board. And then we'll talk. Okay. This is nice. I do. Nice. You're ahead of the game here. Okay, just in a minute.
Absolutely.
No.
Oh, that's really.
Okay, keep working. 30 more seconds. Make sure your picture is nice and detailed. We'll pretend I have more time to write that so it looks prettier. Okay. Okay. Now for this next part, what I want you to do is turn to your neighbor. You're probably the man, you're gonna have to pick who you want to talk to.
Make the right choice.
And discuss between yourselves the answer to these questions or what you drew and what you think is down at the bottom of the ocean. You're going to be timed. You have until the arrow runs out. Okay, so keep track of the arrow. It's roughly a minute and some change. But then when it's done, we'll talk together, okay? Hey Mark, you set? Talk.
Okay, starting to like yours.
No, you first.
This is the main.
Okay, one you the other questions.
There's a few
Yes,
outlets.
But
Fishing.
what I think, my idea, you can disagree with me, but I think we have these plates, we do like plate tectonics. On one no, I think the plate instead of converging, they're actually diverging, and then you see like the magma is actually pushing up and creating these mountains. That's why there's these big mountain ridges, and that's why these.
Scour your fish, crabs.
If it is all about the sit. Give it a couple million years, it'll be all about the
That's that area.
Yeah.
So the graphic will keep this dead man.
The fishes get bigger as you go down, and it gets darker as you go down. I didn't have to the right. All the blackness I was like really, really dark.
Okay, 5, 4,
So those left
3,
mountain ridges.
2, 1. Okay, the arrow's gone.
It's
Oh,
crazy.
nice.
Okay.
That was another.
Okay.
John, let me just interject something. Is this lesson intended to be a follow-up lesson of the last one you did, or like the next lesson in a series?
Well, all lessons are, but are you asking me if this is a concept that they've been introduced to before? Then no.
The last lesson we did was bottom of the ocean,
No.
the tectonics.
They've been talking about plate tectonics, but have never looked at the bottom of the ocean. Does that
Didn't we do that last time you were teaching?
No, we talked about epicenters and we did ratios.
Okay.
I think he talked about it doing it.
I
in
talked about
OMP.
this. This is what I did in OMP.
Yeah, your O&P lesson.
Yes, sir.
Oh, okay.
Okay,
Maybe that was the discussion we were having
Right,
about your own.
right. Now you're getting the full taste of it.
Uh,
Okay, Sai, what did you guys
Oh,
find?
yeah.
What do you guys think?
About the
Yeah, tell
ocean
me.
floor.
What does it look like down there?
Looks like an island covered in water.
Looks like an island covered in
Because you
water.
have the volcano coming up and creating land, but it's submerged in water.
Okay, so what I'm hearing you saying is that there are volcanoes at the bottom of the ocean.
Yes, that's what we're
Wow.
seeing.
Lots of mountains, it's not flat like a sandbox, it is crazy.
Okay, okay, I like your idea. What about over here? Ty?
There's deep trenches.
Deep trenches. This is another good idea. What makes you say there are deep trenches?
Because there's like areas that go really deep. What am I looking for? There's parts that go further down than the normal sea level.
Okay.
And I would see that. And down there, there's like lava tubes and tube worms. And it's really, really dark.
Cool, Nate, what do you think about that?
Exact same thing. I feel like it's really, really dark, but I think like as you go further down, like it just drops. Like I don't know, like it goes like this and then like yeah, it's in a sense trenches.
Yeah. Okay, I heard a Brian. What was that?
Yeah, I'm just, I went a different route. I went the route of what's actually down and what would I expect to
Oh,
see.
tell me what do you expect to see?
I expect to see a lot of fish, a lot of rocks, plant life, crabs and scavenger types fish, ocean floor.
Okay, I like it a lot. Very good, very good work, very good thinking. Let's talk for a minute about the ocean floor. Scientists, well, because here's what we're gonna do. We're talking about the ocean floor because this is part of plate tectonics. I mean, oceanic plates are parts of plate tectonics. And so what we want to do is discover, to investigate what is down there and see if our findings will agree with what we've already learned about plate tectonics. Okay? The more we look into this, the more you think you're going to be surprised about what's down there. It's fascinating. It really, really is. Hold on to your socks, everybody. So scientists have been wondering what's on the bottom of the ocean for hundreds of years, but haven't been able to tell. Why do you think that is? I want to see hands. I see one hand. There's two, there's three, there's okay, perfect. Brian,
They can't get there.
what do you mean?
I mean, you can get to the ocean floor on certain parts of the land, but if you're trying to go into the middle of the ocean, to actually see what's there, you can't get there. I mean, how can you get to the bottom of the ocean when it's miles deep, when they're a few miles deep?
Okay, Sai, do you agree with Brian?
Yes.
Do you have anything else to add?
Well, I would say we just didn't have the technology. Like Brian talked about those like fishes and coral. That's all. A lot of those are only about 100 feet deep. But beyond that, I don't know, we created myths and legend to kind of explain it, but we couldn't see it ourselves.
You just said something about technology. Talk a little more about that.
Well, technology, we didn't have like submarines. We didn't have like pressurized system. We couldn't send the robot sonar, perhaps. Who knows? And I don't know, because we see like, you pull up this picture, we see it's flat and it's blue, maybe there's some birds flying over, there's some clouds, but underneath always remains a great mystery.
Like, I think, in addition to that, I think, submarines can go down there, but I've heard, like, they can only go so far deep, and the pressure is just, will just collapse them if they go too far down. Is that true?
This is true. This is true. Pressure increases linearly with depth. The deeper you go, the more pressure there is going This is why humans can't go down too far. Submarines can take us further, but even they cannot fall down somewhere like the Mariana Trench, the deepest trench in the world. So, talk to me about what technologies we have nowadays that can help us see what's down there. Nate, I see you thinking.
I was like trying to go off what Dan said earlier about like sonar stuff, but like what's the word? Yeah, not sonar, but like waves, and that we can get like a 3D image of.
Your echolocation from bats.
Yeah, something like
Thank
that.
you, Dan. Any other technologies, maybe?
Well, it's like sonar, isn't it? And sonar sending sound down to see how far it goes and then bounces back up.
Sonar is just like echolocation. And that's what we're going to be talking about today, is sonar. But, just so everyone's aware, there are also other technologies like submarines, like flashlights, that have helped us be able to see in dark places. But today specifically we're going to be talking about sonar. Because sonar is a relatively new technology. In terms of the history of technology in the world, sonar is very recent. In fact, it wasn't developed fully until World War II. Why do you think that's the case? Think about that. Take about 10 seconds. Think about why sonar would be important in a war. Hi, Brian.
Well, it gives you a head start on when the enemy or when something is coming toward your way, which you need to be aware of, like a early warning.
Like an early warning system. Nate, I saw you. I
Um,
saw recognition with your face a second ago.
Just basically what he said, because I guess that's when submarines were coming in, and so maybe you can use sonar like to see if like to know if there's anything coming, like particularly enemy submarines.
Sai has an answer.
Oh, Sai, let me hear it.
It's Dan's answer, but I'm gonna tell you.
So,
It was used to detect the German U-boats.
German U-boats. Yeah, you're all right. Every one of you is right. Sonar was developed long before this, but it wasn't refined until World War II because German U-boats and torpedoes in particular needed to be identified. You guys are all spot on with this. Yeah, which is really critical in a war. And after the war, this project was kind of commercialized so that we have them now. It was actually sold to the United States. But during the war, this guy named Harry Hess, this guy over here on the left, he was sitting on one of the battleships that happened to have sonar technology. And this guy is a famous geologist. And it is true to every scientist's core nature that he's going to probably want to experiment with the world. And so rather than looking for submarines, he said, why don't we do ourselves the favor and map the bottom of the ocean? Just as, we happen to be driving right on top of it and we have this cool new technology. Let's just see what's down there. And what he found out really surprised him. But let's take a minute and look at how sonar works. Is anybody familiar with how sonar works? I see a yes, no, yes? Talk to me.
It's sort of like, I want to say it's like ultrasound.
Like ultrasound?
It sends out, I can't remember if it's about sound waves or like,
Okay,
I can't remember what type of waves that go through the,
but it sends out waves of some kind.
I think they come back and then they're either different color, different length, depending on what they find or how deep down they go.
Okay.
How soon they come back.
This is what's going on here. So you don't need to worry about any of these words. I just want you to get a visual for what's happening. The boat will send down a wave. You're right. It's not a sound wave or even a light wave. It's something else. We don't need to worry about that. What we need to worry about is how long it takes to get back. The wave will come down this way and it will go right back up to the boat. And how long it takes to get back will tell you how far away that thing is. And then the computer will map it like this based on color. Where blue means it's further away, and as we get closer to red, that means it's closer to the boat. So blue means deeper down, red means closer up. Okay, so what does blue mean?
Deeper down,
And red means?
closer up.
Okay, all together, blue means?
Deeper down.
Red means?
Closer up.
Okay, now just you. Blue means?
Deeper.
I wanna hear blue means.
Oh,
Deeper down.
Blue means deeper down.
Okay, ready? 1, 2, 3.
Blue means deeper down, red means closer up.
Perfect.
Size deep.
Perfect. And this is an image that we've got.
Oh.
This is the actual stuff. Nate, what do you think about this?
It's interesting how like those certain parts, like the ones that are closer up, it's not like a big like mass. I guess it's like a little bump, I guess you could say.
Mm-hmm.
But yeah, it's interesting how the red is there and everything else is just like deep around.
Like everything else is deep around. And just this range right in here.
Yeah.
Any other comments on this?
Yeah, at least, how wide could one ship send out those beams? Could that?
That's an excellent question. I don't have a good answer for that. But what is this image telling us about how wide the range is?
It's about 50 meters to the first line.
Thank you.
From
We know that this, from here, the bottom down here, to about this far away is 50 meters. And this is the radius of a circle. Yeah. So the first is 50 meters away. And if this was staying true to the trend, this is probably 100 meters, and then 150, and 200 meters. Pretty big.
Away, but not down, right? Away from the boat.
Like, think like down in front.
Okay.
spherical.
Yeah. This is a conical section of a sphere.
So,
Those words.
so just to follow up, all of a sudden I'm thinking about somebody drove a boat around every part of the oceans of the world to do this.
A big boat.
That is correct. that is correct. Somebody had to drive boats everywhere. So, what we're going to be doing is using sonar technology to figure out what's at the bottom of the ocean floor. I'm not going to tell you what's down there. I'm going to give you an image like this, and you're going to work together to map it out on a graph based on the color coding. Because blue means deep and red means
Close.
close. Very good. Okay.
And what is the green?
The green's somewhere in between. There's a scale that goes from blue to red, and green's right there in the middle with yellow.
Keep that shadow.
You'll see, because it's not so. Let's take a look at this example.
Wow.
This is probably a more accurate image of what you see most commonly.
You see where it is? It's kind of like in the middle between North America and
Right. Good identification, Dan. Up here at the top right, this tells us where in the world this is located. This is right in the middle of the Pacific Ocean, or the Atlantic, excuse me. Right between the States and Africa, Europe. Yeah. And then over here on the left-hand side, this guy tells us how deep and high it goes. And when you're graphing this, you don't need to be super particular with like, if you're looking at this color and you can't decide whether that's orange or green, you can just pick somewhere in there. You don't need to be, this doesn't have to be spot on. We're just gonna get a general idea of what this looks like. Okay? So. Any questions? No? No?
So you want us to draw this ourselves, or something similar to this?
Well, I will give you is a graph like this. Oh, okay. And it's going to be your task to mark how deep this is in depth. The depth is on the y-axis here. Yeah, and it's going to follow the color coding. And then on the bottom it says distance along the profile. This just means from left to right down the white line. Yeah. So what you're gonna get when you're done is a profile or a sideways view of what's going on now. Does this make sense?
Yes.
Now when I taught this to my students, each of them had their own smaller one and they worked in pairs, but they're still at the school. So I just put those up on the board for you. Unfortunately, I don't have those. I can't print out color copies here on campus for you. So you're more than welcome to try this right now.
So this is like a aerial view.
Yes, this is an aerial view, and what they're drawing is going to be a sideways
We're
view.
gonna do a side view,
Mhm.
what that looks like.
Right. The aerial view is going to give us the sideways view. So that's all I have for you right now. You're more than welcome to try this out if you want. I imagine it's going to be difficult without having one in front of you and with a ruler. That's what my students had to work with.
It's all right, let's go a few more minutes and see what we come up with.
Oh, great. Well, you know what? If we're going to do that, let's start together. So on the bottom, it says distance along the profile. Let's take the first point over here. And I'm going to look at this piece right here. Just call it my first point. All right, what color is over there on the edge of the white line side? It's blue, yeah? So we pick something down here in blue. What do you want to call that depth?
5,000.
You want to call it 5,000? Sounds good to me. It looks like a light blue. So we're going to mark on that first line 5,000. Perfect, just like that. Excellent. Okay, let's go ahead and just move to the next point like this. Dan?
I would say it's about 4,000, 4,500.
Somewhere between 4,000 and 4,500. Sounds good to me. Anybody disagree?
I agree.
You agree? Okay. Wish I had my ruler. Okay. What can you guys tell me now about this range between here and about here?
Kind of dead.
Kind of steady? Where's it steady between, Nate?
That last arrow to that little circular thing around that, in between there, right?
In terms of depth.
I'd say around 4,000, around there, 4,000.
Right, it's right here on this orangish, maybe 4,500.
Yeah.
So this is fine if the next 3 or 4 or 5 points you just want to drop.
Well, it looks like it dips down about where your fourth arrow is, it looks like it's down.
Yeah, there's a little blue section right here, so it'll drop deeper there. Good. Okay. This is how this process goes. I know we're running out of time, but I do want to show you what this looks like because it's magnificent. Get all excited about it. How do we feel about this? Do we want to continue mapping, or do you want to see what it looks like when it's all done?
I want to see what it looks like.
Oh, I want to see hands. Who wants to continue mapping? Who wants to see what it looks like? Okay, there it is. Okay. So this was the process. We did that in groups, looking at different parts of the ocean. But this is the profile of what we were just looking at.
Starting at 5,000.
Right, there's that blue dip that you were talking about right here. And this is more continuous than what we were doing, obviously. All right, what do you notice, Ty? Just tell me, describe to me what you're seeing.
Bunch of ups and downs.
A bunch of ups and downs. When we're talking in terms of science, try and be more explicit or try and be more descriptive. When we're talking about depth, for example,
Peaks and troughs.
peaks and troughs, these are good words. Excellent. Talk to me about maybe maximum height, minimum depth.
Looks like the lowest point is around 520
520 what?
meters.
Very good.
is highest point 220 meters?
220 meters.
2,000.
Yeah, you're right. Very good. 2,000. That's incredible. It's humongous.
And it looks like it's, like he was saying, there's peaks and troughs, but overall, it looks like it's not troughing lower than the one before. It's just kind of,
Working its way up.
yeah, working its way up to that peak.
So what can you
And
say
then
about
it's
the
like
area in
it's
the middle?
Split right
Yeah,
down in
right.
half, and then starts going down again.
Very good. There's this very strange geological feature we have going on here, where this mountain range, for the most part, has a humongous drop in the middle that almost goes clear back down to where it began.
Huh.
Huge. And just to give you an image, we'll call this the bottom of the ocean, which rests about 5,500, maybe 6,000 meters down here. This mountain range is going like this. Clear almost up to the top of the ocean. It's humongous, smack in the middle of the Atlantic Ocean.
6,000 meters to,
It's,
so it's rising 3,000, so it's rising almost 3,000 meters.
what's rising here is almost 2 miles, yeah, long. Which, I don't know how to give a good perspective of that.
Oh, it's
This is bigger than any
15,000
building we've
feet.
ever created. This is really big stuff.
15,000 feet. 3 miles, actually, almost 16,000 feet. I mean, that's a
Are you
big
turning
amount.
are you turning meters into feet? To turn
Well,
into miles?
So what did
These
you
are in-
say,
these are in
3,000 meters?
Yeah, these are 3,000 meters.
3,000 meters.
2 meters.
That's 3 feet per meter, so that's 9,000.
I think there's about 1,500 meters in a mile. If I'm doing that right.
So you're timesing 1,500 to 3 to 4,500 meters times 3 to turn it into feet. Is that right?
250 feet. No, I was just trying to convert meters into miles. There's roughly, you can look
Yes.
this up if you'd like.
So all
So
I'm
rather
saying
than
is
skipping, I'm
that,
skipping the feet. And I'm jumping straight from meters to
I'm
miles.
just saying like Mount Timpanogos is 11,000 feet, which is dwarfed by that thing.
Yes, that's
Um,
correct.
I mean, you look at any mountain that you've seen and
This is the biggest mountain range in the world, actually. Hiding peacefully at the bottom of the ocean. But what we're gonna do next time and what you need to think about as you're getting out of here is how in the world this possibly got down there. And why does it have this very strange jump gap here in the middle? And what that possibly means in terms of what we've already been learning about plate tectonics. Okay? Is that what we're supposed to be doing?
We're supposed to be thinking of how that trench came in. To the-
Okay, how this trench came in here. And Dan, what else?
And to kind of figure out like why, what does that mean when it comes to, I guess, plate tectonics.
Yep, plate tectonics, very good. All right, any questions?